let's now start talking about the calculus involved with curves described parametrically. So if I've got a plane curve, described by a set of parametric equations, then remember how the chain rule says this. If I differentiate y with respect to, say, t, boy, I can't enunciate today. Notice how the chain rule says I can think of this as derivative for y with respect to some intermediate variable times the derivative of that intermediate variable with respect to t. We typically use u's in the first semester calculus. I'm using x's this time. But now, if you divide both sides by this, it simply says that for a plane curve, the slope of the tangent line can be interpreted by the ratio of the derivative for y with respect to that parameter t to the derivative of x with respect to that parameter t. So I'm starting a list here of some tools I want in our back pocket. And to put this to practice, I want to sketch a plane curve using what I refer to as my analysis of intervals technique. So here's my approach. Notice that dx dt is equal to this. And dy dt is just this. So that in the end, the slope of the tangent line to my curve is nothing more than the ratio of the second to the first. Would that be this? Now, what I refer to as my analysis of intervals technique says the following. To sketch this curve, we're going to look for points on the curve at which the tangent lines are horizontal and vertical. And I think the tangent line is going to be horizontal when this fraction is equal to 0. That means this numerator is equal to 0. That means dy dt is equal to 0. And likewise, I'll have a vertical tangent line if my denominator, or dx dt, is equal to 0, which is going to happen twice. So given that at these three interesting t values, 0, 1 over root 3, and it's negative, then I will consider intervals. For t. So let's see, I had three critical numbers, didn't I? The smallest of which is negative 1 over root 3. So let's look at this interval. And the next critical number is at t equals 0. So let's look from here to here. Then from here to here. Oh, can I do it? My goodness, I can't. All right, there we go. And lastly, to the right of the third critical number. And let's see what happens with x prime and y prime. Now, technically speaking, shoot, where am I at? So for x prime described here, notice I've got two zeros. And if I'm outside those two zeros, I'm positive. If I'm inside, I'm negative. Here I'm outside. Here I'm inside. Here I'm inside. There I'm outside. And I think dy dt is going to be positive when t is, and negative otherwise. But what this says about x and y is the following. It says that x is increasing but changes decreasing over this interval, decreasing over this interval, increasing over this one. Does that mean it moves to the right, then to the left, to the left, to the right? Whereas when you look at the signs for y prime, it tells me going down, I've lost track, going up, and then going up. And what this means for the curve, as I'm moving in a rightwardly downward direction over the first interval, then in this direction, then in that direction, and then in that direction. So trying to put this all together, I will definitely fail, because technically speaking, I don't have the room. All right, here I go. So try to remember what dx dt is, try to remember what dy dt is. Now I'm drawing the XY coordinate plane. Neither one of these axes is t. So t is my parameter in a sense being removed when I sketch the graph, although used in terms of tracing out the curve. So here I go. I think I've got those three interesting critical numbers. Let's start with the easy one, t equals 0. When t is equal to 0, we're talking about a point 0, 0, the origin. Because when I plug 0 for t in this equation, both x and y are equal to 0. Now, to show that clearly to the reader, let me go ahead and plot that point. It's the origin, and maybe in blue, I'll remind myself what t value gave me that point, and t was equal to 0 specifically. However, that was obtained by dy dt. And dy dt being equal to 0 simply means my tangent line is going to be horizontal. Now let's look at the other two interesting critical ones. Let's do the small one first, -1/√3. The corresponding point of the graph, if I plug -1/√3 in for t here, I have no idea what it is. So that can give me this. And the y-coordinate is going to be +1/3. Now that black point is generated when t is equal to this blue value. But dx dt is equal to 0 when my tangent line is vertical. I'll put a little vertical dash with my red pen to remind myself of that. Now the only other critical number I missed was, I think, positive, there it is, +1/√3. But when I plug it in for t here, that gives me -2/3√3. I should have symmetry. But the y-coordinate is going to be the same as the last one. That did occur when t was equal to this positive value. But again, dx dt being equal to 0 implies the tangent line is going to be vertical. I'll put a little vertical dash in there. Okay, everybody, now let me put everything together. So putting everything together, it is the case that as t ranges from -infinity to -1/3, I'm moving in this direction. So here's when t is equal to -1/3. Now, if I'm moving in this direction prior to that, I guess I'm coming from this direction. So in black, something like this. Now, as t reaches the value of -1/3, my tangent line is vertical. So as I come to this point, I'm going to make sure I dive in a vertical fashion. I'll show the reader my orientation. Now, as t continues to increase from -1/√3 to 0, not only do I change in moving in that direction, but I get to a point when t is equal to 0 where the tangent line is horizontal. As t continues to increase from 0 to 1/√3, I move in this direction until I reach the point where t is equal to 1/√3, but that gives me a point at which the tangent line is vertical. And lastly, if I exceed that last critical number, I move in the rightward upperly direction. Looks like I got a symmetry, so I'll probably cross myself on the y-axis. I don't know that, but we'll check it. So if you're okay with the sketch of the graph using this new technique referred to as analysis intervals, let's take this one step further. Let me, in addition to drawing the graph, labeling the points at which I'm vertical and horizontal with my tangent lines, but in addition to that, let's go ahead and find all intercepts. Now, to find the y-intercepts, those occur when x is equal to 0. So setting x equal to 0. It happens at 3 t values, 1, -1, and 0. Now, to find those actual y-intercepts, I'll plug those numbers in for t with that equation. So when I plug 0 in for t, I get the y is equal to 0. But of course, I already knew that was one of my y-intercepts. Now, to find the other two y-intercepts, plug 1, or for that matter, -1 in for t, and you get the same number, +1. So I guess I was right, and that technically speaking, I did cross myself tracing out the curve at that y-intercept. And so how about in black, that y-intercept located 0, 1, and it occurred when t was equal to plus or minus 1. So I think I did a decent enough job sketching that graph. But again, use this new technique I'm referring to as analysis of intervals technique.